Hi Izzy, the first question for 7 is finding the angle of elevation of the plane from the ground after 5 minutes. So if we focus in on 7A here, so naturally the plane is constantly flying at 1,000 meters, so that height is always going to be 1,000 meters. We need to figure out the angle of elevation. Where the question might get a little bit tricky is that you need to figure out, if you're travelling for 5 minutes, how far are you actually going? So 5 minutes, if I convert that into hours, 5 minutes is actually a 1/12 of an hour. Okay, so 5 divided by 60 gives me a 1/12. So therefore, I know I'm actually travelling for a 1/12 of an hour. To figure out the distance, I just do speed times time. Okay, so 240 kilometres an hour times 1/12 of an hour will give me 20 kilometres. So in that 5 minute duration, I will travel 20 kilometres, which is also equivalent to 20,000 metres. And you remember, you must convert to the same units because I've got 1,000 metres here, so therefore I have to have that in terms of metres there. Or you could alternatively turn that into 1k and that 20k, which is probably actually a little bit smarter to do that way. So then to find the angle of elevation, I just use my trig ratio tan. Tan is opposite over adjacent, which leads me to tan theta is 1,000 over 20,000. And then if I follow that through, you can see that it comes out to roughly about 2.86 degrees. Okay, so if I proceed on to B now, okay, B just says if the angle is halved, if the angle of elevation is halved, how far has the plane travelled? So given, if we're correct in part A where we've got 2.86 degrees, if I halve that, that's 1.43, and then I'm figuring out how far I've actually gone. Okay, so I set it up again, tan of the angle, but now I know the angle, is opposite over adjacent, and that leads me to this here. And then remembering, as we've discussed in class, when I have my unknown up on the bottom in the denominator, I just do a switch. So these guys just switch positions, which leads me to this line here, and then it comes out to about, I think, 40,059 metres, which seems to make sense, because if it took us 20,000 metres for 2.8 degrees, then it's going to be roughly double. So that kind of makes sense. The last part of the question, let me just reduce that size here. Oh no, that's not good. Hang on. That's a bit better. So the last one says something similar. If I have a quarter of the original angle of elevation, so therefore I've halved 1.43 again into that, and I do pretty much the same thing. So I set it up, tan of my new angle now, which has been halved from the previous question, or divided by 4 from the original, is 1,000 over x. I do my switcheroo, and I get roughly 80,130 metres, which corresponds to 80.13 k. So to figure out how long it took us to do that, I'll go back to my relationship between time, distance and speed, and time is distance over speed here, because distance is speed times time. Therefore, if I rearrange that and solve for time, I get distance over speed. So I've figured out my distance, I've got my speed, so that roughly comes out to about 1/3 of an hour, or about 20 kilometres, 20 minutes. So hopefully that sheds some light on this question. The next question that you've asked for, question 10, is not very clear on the photo, but I'll see what I can do. Okay, so hopefully that helps. Bye.